this K is property of the spring element. That means it is a property of the spring and it is a stiffness of the spring, or it is a force per unit deformation for this spring. Now it has two nodes. One node is I and one node is J. Okay, and displacement at node I is Ui and displacement at node J it is Uj. Force at node I is Fi and force at node J it is Fj. Okay. Now these are the properties of the spring element. Now how we can write the finite element equation for the spring element, that we will discuss. Now first I will write the deformation of the spring element. Now how we can write the deformation of the spring element? Deformation of the spring element is the displacement of this node J minus displacement of node I. Okay, displacement of node J minus displacement of node I, it will give the total deformation of the spring or spring element. Now you see here delta is equal to Uj minus Ui. I think this is not new for you. Okay, next one, axial force on the spring. Axial force on the spring. Now you know the axial force on the spring, and it is the force is equal to stiffness into deformation. Stiffness into deformation, that is K delta. K delta is the force on the spring. You know this relation also. You have already studied, that is force is equal to K delta. Now what I will do, I will use value of delta from here, and I am going to write K Uj minus Ui, that is the force on spring. Now when we write this equation for node number I and node number J, now at node number I you have force, okay, it may be in right direction or it may be in left direction, that depends upon your problem. But what we can say here, force at node I, this equal to the force at node J. That means if this spring is in equilibrium, then addition of or algebraic sum of the all forces, it is equal to 0. That means if Fi is the force at node I and Fj is the force at node J, then addition of Fi plus Fj is equal to 0. Or we can say Fi is equal to minus Fj, or Fj is equal to minus Fi. So when I write this equation or axial force equation for node I will get here, according to equilibrium, Fi plus Fj is equal to 0. Now for this, Fj is equal to minus Fi. Now when I write the equation for node I, it becomes minus K into Uj minus Ui. Minus K into Uj minus Ui. Here this minus sign you can take for Fj or you can take for Fi. That is the property of the force applied. Okay, or that depends upon the application of the load. Okay. Now Fi is equal to minus K Uj minus Ui. For simplicity or for standardization, I am going to take Fi as a negative force. Suppose it is acting in this direction, that is K minus K into Uj minus Ui. Now same thing when I repeat for node number J, I can write Fj is equal to K into Uj minus Ui. Now you see here Fi is equal to minus K Uj plus K Ui, or it is K Ui plus minus K Uj. K Ui minus K Uj. Okay. Now Fj is equal to K Uj minus K Ui, or I can write Fj is equal to minus K Ui plus K Uj. Okay. Now these two equations for two nodes, that we can write in matrix form, and that matrix form we will get like this. That is, you see here, Fi is equal to minus K Ui plus K Uj, and Fj is equal to minus K Ui plus K Fj. Any doubt up to here? Any doubt? If you have doubt, you can ask me. It is same thing to that of the thermal problem. Your equation for spring, it is Fi is equal to K Ui minus K Uj, Fj is equal to minus K Ui plus K Uj, or we can write in short F is equal to K into U, or K into U is equal to F. This is a finite element equation for spring. Now by using this equation we can solve the spring problems, that is assemble the spring analysis we can do by using this finite element equation. See here all these equations are same, that is equations which we have obtained for axial loaded bars. at the start of this subject, that is also K into U is equal to F. Now for thermal problems, it is also K into T is equal to Q, and for spring also K into U is equal to F. This is the finite element equation. That is a simultaneous finite element equation. Here only thing is this K will be changed according to the discipline. That means for structural analysis it is AE by L 1 minus 1 minus 1 1. For thermal analysis K A by L into 1 minus 1 minus 1 1. Now for structural analysis U is your displacement matrix. For spring also U is your displacement matrix. For thermal problem it is a temperature matrix. For force matrix, for structural problem it is force matrix. For spring problem it is a force matrix, and for thermal problem it is a heat flow matrix. Okay, only this is the difference. Now I will take only one problem on this, and then we will go for the next part of the content. Now you take this problem. Here this is a spring assembly. This is the first spring. Now this is the second spring having same stiffness, that is K2 K2. That is these two springs are connected in parallel. Okay, therefore their stiffness will be added. Okay, now this is the third spring. Now you have to discretize this by using three elements. Now from here to here we have one element. Okay, now from here to here we have second element. From here to here we have third element. Okay, now this is your element number 1, element number 2, element number 3. Okay, now this is your node number 1, node number 2, node number 3, and node number 4. Okay, now next one, stiffness of first element, it is K1. It is a spring, therefore it is a K1. And stiffness of second element, can anyone tell what is the stiffness of second element? What is stiffness of second element?
K1 plus
K2 plus K2. Okay, stiffness of second element. Sairaj Shinde. Sairaj Shinde, can you tell what is stiffness of second element? Whether he is here or not. Okay. Okay, you stop your mind. Now, Rutuja Mane, can you tell what is the stiffness of second element? Rutuja Mane?
Yes, sir.
Yes, tell me.
K1 plus K2.
K1 is the stiffness of first element, first spring. Now for second element is a combination of these two springs. What is stiffness of that?
K2 plus K3.
K2 plus K3 is for third element again. Now this is for second element.
K2 plus K2.
K2 plus K2. K2 plus K2, addition of stiffnesses of these two springs, it is your total stiffness of second element. Am I right? Now for third element you have stiffness K3. Now we have this stiffness matrices. Now what is the stiffness matrix for first element? Stiffness matrix for first element. Akshay Shinde, what is stiffness matrix for first element?
So
K1 minus
K1
minus K1 minus K1 and K1. Okay. Now Rishikesh Kumbar, what is the stiffness matrix for second element? Stiffness matrix for second element? Rishikesh Kumbar?
Yes, sir. Minus 2K2. No, plus
Minus
2K2.
Yes, 2K2.
Minus 2K2.
Minus 2K2. Yes.
Minus 2k2 and 2k2.
Minus 2k2 and
2k2.
2k2. Okay. Next, Pandit. What is the stiffness matrix for third element? Pandit?
Yes, sir.
Yes. What is stiffness matrix for third element?
K3
K3
minus K3
minus K3
minus K3
minus K3
K3.
K3. Now, Vaibhav Khade, what is size of stiffness matrix? What is size of global stiffness matrix, total stiffness matrix, or assembled stiffness matrix? Yes, Vaibhav Khade.
Sir, 3 by 3.
Is it 3 by 3?
4 by 4.
It is 4 by 4.
4 by 4.
It is 4 by 4.
4 by 4.
Yes, it has 4 nodes.
4 by 4.
So it is 4 by 4. Okay. Now it is here your assembled stiffness matrix is 4 by 4. Now Shubham Patel, you tell me assembled stiffness matrix. Shubham Patel, whether he is here or not. Shubham Patel. Next, Thorath. Thorath, can you tell me? Srijit Thorath.
Sir.
Yes. Tell assembled stiffness matrix.
K minus K 0 0
Yes.
minus K K1 plus 2 K2
Yes. This one. Minus 2k2.
minus 2 K2
Yes.
0
0, yes. Third row.
third row 0
Yes.
0
Minus 2k2, na?
yes minus 2 K2 okay 2K plus K3
2k2 plus k3. Yes.
minus
Next.
K3
Minus k3. Next.
0
0.
0
Yes.
minus K3
Yes.
K3
Yes. Correct. Now you see this one. This is your assembled stiffness matrix, and this one is finite element equation. Your displacement matrix is U1, U2, U3, U4. Okay. Here 4 nodes. Therefore, there are 4 displacements. So your displacement matrix is U1, U2, U3, U4, and one more. Here there are 4 nodes. Therefore, force matrix has also 4 components. That is F1, F2, F3, F4. Okay. Now this is your assembled finite element equation. That is K into U is equal to F. Next one. Next, you apply the boundary conditions. You see this boundary. What are the boundary conditions here? Here, what are the boundary conditions? Saurabh Pawar.
Yes, sir.
What are the boundary conditions here?
F1 and F4.
Here, F2 and F3 are F4 are the forces. That is, now you tell me for displacement. Displacement. What are the displacement boundary conditions?
0
0.
for
U1
F1.
is 0 is at node number 1. It is 0. That is U1 is equal to 0. Okay, and at node number 2 there is a force F2. Now what about the force at node number 3?
0 given.
0. Yes, it is. If it is not given, then also it is 0 because there is no any force, and here it is 50. Am I right?
50 F1 is equal to 50.
Yes. This is minus 30. This is 50. This is 0, and here it is a support reaction. Am I right? At node number 1 there is
Yes, sir.
support reaction. Yes. Now after putting boundary conditions, you have U1 is equal to 0. Okay. F1 is equal to, I have kept F1 as it is. Okay, you can understand it is support reaction. Or now F2 is equal to minus 30. It is given in the problem. F3 is 0. At that location there is no force. And F4 is 50. Here F2 is in negative direction. So this F2 is minus 30. Okay. Now U2, U3, U4 we have to calculate. Now for calculation of U2, U3, U4, what you have to do? Here you write the second equation. Second equation, minus 4 into 0. 16 into U2 minus 12 into U3. That is 16 into U2 minus 12 into U3 is equal to minus 30. Now third equation, minus 12 into U2, 15 into U3, minus 3 into U4. Okay. Next, minus 3 into U3 and 3 into U4 is equal to 50. Okay. Now here we can remove the first row and first column because you have U1 is equal to 0. Here same strategy which we have used for structural analysis, that we can use here also. Therefore your system of equations will be reduced to 3 by 3. It becomes, you see this second equation, 16 minus 12, okay, 0, minus 12, 15, minus 3, 3. It is U2, U3, U4, and on this side there is a minus 30, 0, 50. If you are doubt up to here, you can ask me. Okay, is there any doubt? If you are not get any step, you can ask me. Now you solve for U2, yes. Yes.
रिमूव का केलं सर डबल सांगितलं जरा.
You see this. If I write the second equation, what we want to calculate? We want to calculate U2, U3, U4. Now for U2 we have to write the second equation. Am I right? Now when we write the second equation, you see this second, minus 4 into 0. Okay, it becomes 0. Next 16 into U2. Okay. Next minus 12 into U3. This 0 into U4, it is 0. That means 0 plus 16 U2 minus 12 U3. This equal to minus 30. Okay. Now you see this equation. Is it same? Okay. Now third equation, minus 12, 0 into 0 is 0. Minus 12 into U2, 15 into U3, minus 3 into U4. This is equal to 0. That means minus 12 into U2, 15 into U3, minus 3 into U4, it is equal to 0. Okay. Next, fourth equation, 0 into U2, it becomes 0. Again this 0 into 0, it is 0. That means that first two terms are 0. Next, minus 3 into U3, 3 into U4, it is equal to 50. Now here from in second equation, third equation, fourth equation, first terms are 0. Therefore not necessary to consider that 0 terms because that will not affect on your addition. Okay. So I have removed these terms. Okay. When you solve by taking these terms also, it will not affect on your solution. So you can remove these terms. Or now your system will be reduced to this one. Have you doubt? Is it clear?
Yes, sir.
Okay. Now you calculate U2, U3, U4. Calculate it fast. You can make this term 0. You can make this term 0. You will directly get the U4 into something. Can you do yourself? If you can do, I will go to the next term.
Yes, sir.
Can I go for next?
Yes, sir.
Okay. Now you see here, you have got, or after calculation you will get these answers, U2, U3 and U4. Okay. U2 is equal to 25.83 millimeter, U3 is equal to 9.17 millimeter, U4 is equal to 5 millimeter. After getting this U2, U3, U4, what you have to do? You go back to here. sorry, not here. You go back to first equation here. Okay. Now you put value of u2 in this equation, in first equation, that is 4 into 0 minus 4 into u2, that is equal to f1, that is minus 4 u2 that equal to f1. Now what is f1 here? F1 is yes. This is your u4. If you are doubt, you can ask now. Otherwise, I will move to the next concept.
सर ते लास्ट सांगा की जरा आर कसं काढलं परत.
Now you have u2 here, u2. Now you put u2 in this equation. Now you see this 4 into 0. I will clear this all the things. You see here, you have this is u2. u2 is equal to 5 millimeter. Okay. Now you put this u2 in first equation. Your first equation is this one. You see here, 4 into 0 minus 4 into u2. Okay, minus 4 into u2. It is equal to f1. Now f1 is equal to 4 into this 5, it is minus 20. Okay. Now that is your support reaction R. Okay. That is your support reaction R. Have you got it?